All right, so let's see. All right, so put your names on that and pass that on in. If we go back a slide, what does that one say?
It's what you just answered. It's the much further away from the shows some distance.
Oh, there was a number 9 there?
What was it?
I didn't realize there was a 9 on that one. Oh. So number 9, which cell is has the largest chi-squared value? This cell, 91.7. So first class that are alive. And what does having the chi-squared tell you about the variables? It is the furthest away from the mean. So this kind of verifies that people who got first class tickets had a better chance of surviving. I didn't know. Sorry about that. I realized it was. And we're going to be on page 55. Once you get those homeworks, copy it. Got some. So copying, done.
Yeah.
Is that wrong?
Yeah, I'm here.
Retarded?
Yes, I will.
Oh, okay. Yeah, do you want me to change it to an L for it?
Excuse her.
Yeah.
What? All right, if I change you, that means I'm going to turn Catherine into an unexcused absence. Any more homework out there? Yeah. Pete, did I get you?
Yeah.
I did? I forgot. Any more still copied down? Hold now. Thank you very much. Thank you very much. Thank you very much. Thank you very much. We are on page 55. Page 55.
I was like, yeah.
Any more homework out there? Then? Oh yeah. Oh yeah. Ready. All right. So page 55 in the notes, chi-squared test for independence, part 2. It says, after calculating the observed, expected, and chi-squared values, you add the chi-squared values to obtain the chi-squared test statistic. Okay? So on this particular board, I'd add the 91.7, 7.3, 11.0, 19.1, so on and so forth. So that's basically the sum of the chi-squared. Okay. Use chi-squared to calculate the p-value to make the decision to reject or fail to reject the null hypothesis. However, a good method for computing the degrees of freedom for this test is different than the goodness of fit test. Recall the degree of freedom is the number of categories subtract 1. Well, when you have a table, you're going to say my degrees of freedom are the number of rows, so I have 3 of those, and the number of columns, I have 5 of those. This is back to our hurricane one. And you go 3 minus 1, which is 2, and 5 minus 1, which is 4. So the degrees of freedom of this particular one is going to be 8. So this is going to allow you to do a degrees of freedom on a chi-square distribution using 8 degrees of freedom. So degrees of freedom when you have a table is the number of rows minus 1 times the number of columns minus 1 of your data, not of your totals of your data. Okay? Make sense so far? So in the display, there are 14 chi-squared values for each cell. These 15 values add up to 4.662. Okay? So if we were to walk through that. With 8 degrees of freedom calculator, let's show how the calculator is going to work with this. So it's time for, guess what? Who's coming to the story? Desmos. Man, we gotta love these people. Okay, so. Yes, it is. All right, so the degrees of freedom for these is going to be rows minus 1 times columns minus 1. So in this case, we have 3 rows minus 1, 5 columns minus 1. So 2 times 4. So we have 8 degrees of freedom. Okay? So, Desmos. All right, so we're still doing a chi-squared distribution, so go over to functions, find chi-squared, and it's so if you're not finding this chi-squared distribution on your phone, see if there's an update to Desmos, your app. So we have 8 degrees of freedom on this, so we have that. So that's the 8 degrees of freedom chi-squared curve in this situation. This has to do with the Atlantic and Pacific Indian Oceans in category 1, 2, 3, or 5, 4, or 5 are hurricanes. They had already done the work for us. So they said if you take these 15 values, all the chi-squareds add up to 4.662 with 8 degrees of freedom. So remember, on these, unless they tell you opposite, you're always going to do it to the right. So we're going to do chi-squared of 4.662 to the right to infinity. Yes. So type in 4.662. All right. So we wind up with 0.793 in this case. That's what they said, 7.93. I love it when we match up with the notes. So our p-value is 0.793. This is a very high p-value, meaning that we're testing usually against 0.05, right? Which tells us that the distribution we were seeing could easily occur by random chance, meaning our data collection on those storms up there with the 3 oceans and the 5 categories of hurricanes with the degrees of freedom of 0.793, that's pretty high. So in this case, that happened by mere chance to have that piece of data. This p-value is greater than any reasonable value of alpha, so we fail to reject the null. There is not enough evidence in this data that the ocean and hurricane intensity are dependent on each other. Informally, this tells us we can't use one variable to predict another. An Indian Ocean hurricane is likely to be a category 5 as any other hurricane, for example. The assumptions that the goodness of fit test sampling must be random. Okay. So the goodness of this, sampling must be random, and each expected value must be greater than 5. In this scenario, the random sampling assumption is hard to check. Are these hurricanes truly random sample of possible hurricanes? I'd say no. This is probably over a year's time, or 2 years, or whatever. One thing is clear, however, any expected value is less than 5. This is a chi-square test that we shouldn't put too much faith in. Ooh. So, I don't believe there's a backside to this paper. So, basically, you're running through all the chi-square situations. So, if you would, give page 135, 136 a look at, and we'll go over it tomorrow, see how we do. It's been asked, we have a test or quiz this week. The answer is no. Sorry about that. I know you guys were like waking up this morning going, I hope we have a test. Oh, that could be. Yeah, there'll be a pop quiz tomorrow, April Fool's. It's like, dude, that one sucked.